All right, guys. I have switched on the recording. Keep reminding me in case I forget such things in the next classes. So y COM क्या हो जाएगा? ये भी हो जाएगा 2. And that's very obvious that if you have these three particles, then its center of mass will also lie along the line joining these three particles. And yes, we are having that coordinate. This is the center of mass. And there was no need to actually compute this. ये हम symmetry से भी कह सकते थे. All the particles were having same masses. Center of mass will be at this point. So all will do number 2 now. All will do number 2, guys. Whoever gets the answer, let me know that. Let us see this one. No one has given me the answer yet. Two particles have equal masses initially at rest. Move towards each other. Right? They are having equal masses. They are moving towards each other. ये मैंने डायरेक्शन बना दिया। एंड अंडर द म्यूचुअल force of attraction and at an instance when the speed of A is v, ये मान लिया A है, इसका speed v है, the speed of v is 2v, इसका speed 2v है. What will be the speed of the center of mass? Now you again have to use directly the formula. This is just moving in a straight line, तो assume कर लो x direction में move कर रहा है, right? तो अब what do we use here? X of center of mass क्या था? m1 x1 plus m2 x2 divided by m1 plus m2, right? So we can use this formula when we have been given the position coordinates of these two particles. तो वैसे ही अभी velocities दिए हुए हैं, so you will get velocity of center of mass if you differentiate this equation 1. तो क्या हो जाएगा m1 v1 plus m2 v2 divided by m1 plus m2. So just use that. So velocity of center of mass into velocity क्या हो जाएगा m into v. Mass into velocity, now it will be m into minus 2v because 2v is the speed. Here the direction is opposite, so you have to use minus 2mv divided by the total mass. They are having equal mass, so m plus n. So what do we get from here? देखो m तो कट हो गया, बचा क्या? v minus 2v by 2. So that will be minus v by 2. That will be the velocity of the center of mass. So here it just asks what is the speed of center of mass. So speed क्या हो जाएगा? v by 2. There is no need to include negative sign in the speeds. Is this clear to all? Is this clear, guys? Okay. Then number 3, Monit will do. बाकी सभी करेंगे. All will give me the answer, but especially I'll ask the answers to Monit, Omkar, and Kaushik K. Okay, this number 3. It's similar to what we did now. You have to do them. बाकी सभी जो जिनको आंसर मिलेगा, they will let me know in the chat. Okay, so here we can see two bodies of the masses. Their masses are given here, 6 kg and 4 kg. Their velocities are given. You have to find the velocity of center of mass. You again use the same formula. So I'll directly multiply one mass into this velocity. What we will get? 30I minus 12J plus 60K. And then other mass into this other velocity. So that should also be added up. So 40I minus 8J plus 20K. And then you need to divide this complete thing by 10. We did this question in the last session in the quiz, right? तो उससे हमें velocity of center of mass मिल जाएगा. Just add them. 30 plus 40 70 by 10. तो ये क्या हो गया? 7I minus 12 minus 8 minus 20 by 10. That's minus 2 J cap. And then 60 plus 20, 80 divided by 10. That's 8 K cap. And here you get the velocity of center of mass. Number 4 we will do quickly. Not more than a minute, guys. Okay, let's take 2 minutes to do this number 4. Quickly, all will do this. So let us check this one now. Three identical uniform spheres, each of mass is 1 r cap. You have to find the center of mass of the system P from P. Okay, so this coordinate will be 0, 0, and they are identical. So let us consider their radius to be r. तो अगर radius r consider किया तो ये point क्या हो जाएगा? Just see, ये r हो गया, ये r हो गया, so it will be 2r, 0. ये क्या हो जाएगा? 4r, 0. Now just figure out, just use the expression. So their masses are 1 kg. So just multiply that with the x coordinate here. You will get 1 into 0 plus 1 into 2r plus 1 into 4r. And you divide this by the total mass 3. So when you add them, you get 2r. And that should be very much apt here. Right? So we get 6r by 3, that's 2r. So our center of mass कहाँ हुआ? यहाँ पर lie कर रहा है. Everyone got this, guys? Understood everyone? Number 4. Whereas number 5, let us do this one also quickly. 3 particles of masses are placed at the corners and locate the center of mass. So I'll give you the diagram here, because for different particles at different corners, all will get different answers. So let's say this is an equilateral triangle which you have been given. Assume 3 kg is here, 1 kg is here, 2 kg is here. Find out the center of mass now. Quickly, guys. So here we have given these things. ये हमने क्वेश्चन किया था in the last session. Just take the coordinate. Assume करो कि ये origin पे रखा हुआ है. तो साइड इज 1 मीटर, तो इसका कोऑर्डिनेट क्या हो जाएगा? 1 0. व्हाट विल बी इट्स कोऑर्डिनेट? देखो इट विल बी एट द सेंटर, तो ये 0.5 हो जाएगा क्योंकि साइड लेंथ 1 है, तो 0.5 एंड देन अप्लाई द पाइथागोरस थ्योरम, तो ये क्या हो जाएगा 1, ये है 0.5, सो यू विल गेट दिस एज 1 माइनस 1/4 रूट ऑफ दिस, तो √3/2। चलो इसको भी मैं 1/2 लिख देता हूँ। नाउ यू कैन इजीली गेट द सेंटर ऑफ मास, देयर इज नो नीड टू डू इट. Level 2 questions we will do, and in this also we will skip those questions that we did in the quiz. Okay, so everyone quickly do this number 6. The center of mass of three particles is at this one. You have been given the center of mass. ये हमने किया था कल क्विज में. Let's skip this. We will not do it again. And let us do this one, number 7. 4-point masses are respectively having the mass from the corners of a square of side A. Right? ये square मान लिया, सारे side A है. Point masses यहाँ मान लिया point P, तो ये हो गया Q, ये हो गया R, ये हो गया S. तो point P का कोऑर्डिनेट क्या होगा? Let us assume this is at the origin. तो Q क्या होगा? A0. R का कोऑर्डिनेट क्या होगा? AA. S का कोऑर्डिनेट क्या होगा? 0A. And the center of mass will be farthest from which vertex or vertices? सबका masses देखो, ये है 1 kg, ये है 2 kg, ये है 3 kg, सॉरी ये भी है 1 kg, ये 1 kg है P, ये भी 1 kg है, और ये 2 kg है, और ये 2 kg है. You actually do not need to compute this. अगर आंसर मांगता है center of mass क्या है, then you can do. But here it just says center of mass will be farthest from which vertex. So if you wish, you can find the center of mass, or you can also do it normally. So it will be definitely farther from masses P and Q, or masses situated at P and Q. Yes. Because क्या है देखो, इसका सेंटर ऑफ मास, इसका सेंटर ऑफ मास क्या होगा? एग्जैक्टली एट द मिड पॉइंट. इन दोनों का सेंटर ऑफ मास क्या होता होगा? एग्जैक्टली एट द मिड पॉइंट. अब ये जो है, इसका मास क्या होगा? 4 kg, राइट? 2 kg प्लस 2 kg. ये जो है, इसका मास होगा 1 kg प्लस 1 kg, दैट्स 2 kg. So if you observe, these masses are not equal. So at the center, there is no chance the center of mass will be there. So definitely it will be near to this 4 kg. So of course it should be farther from P and Q. Okay. Number 8 quickly all will do. Let's check this one. Three identical spheres of mass m are placed at the corners of equilateral triangle of side 2m. Three identical spheres are placed, right? तो उसको हम point mass consider कर सकते हैं, right? Side is 2 meters. Taking one of the corners as the origin, what is the position? You have to now find the position vector, guys. Position नहीं find करना है. So let us suppose जो position मिलेगा, क्या मिलेगा position? चलो निकाल लेते हैं जल्दी से. ये मान लिया origin पे, इसका हो जाएगा 0 0, इसका हो जाएगा साइड 2 0, इसका हो जाएगा 1 एंड देन फाइंड यूजिंग पाइथागोरस थ्योरम. ये 1 हो गया, ये 2 हो गया. हमें ये चाहिए y कोऑर्डिनेट के लिए, सो दैट विल बी रूट ऑफ हाइपोटेन्यूज स्क्वायर माइनस 1 साइड स्क्वायर. तो ये क्या हो जाएगा, सॉरी 2 स्क्वायर माइनस 1 स्क्वायर, ये हो जाएगा रूट 3, राइट. एंड नाउ इफ यू फाइंड द सेंटर ऑफ मास, यू गोना गेट हियर, जस्ट ऐड द पोजीशन कोऑर्डिनेट्स. तो x का पोजीशन कोऑर्डिनेट क्या हो जाएगा, जस्ट ऐड देम ऑल. 0 2 1, तो 3 हो जाएगा एंड डिवाइड बाय द टोटल मास. टोटल मास विल बी 3m, तो ये हो जाएगा 1. y सेंटर ऑफ मास क्या हो जाएगा, जस्ट ऐड द y कोऑर्डिनेट्स 0 0 रूट 3, तो रूट 3 बाय 3, ये हो जाएगा 1 बाय रूट 3. सो व्हाट डू यू गेट, द पोजीशन कोऑर्डिनेट मिला हमें 1 and 1 बाय रूट 3, बट यू आर आस्क्ड द पोजीशन वेक्टर. व्हाट विल दिस बी, I cap into 1 by root 3 j cap. I cap plus 1 by root 3 j cap. That will be the position vector. Okay, guys. Next one we're gonna do here. ये हमने किया था. We'll not do this. Number 10 all will do quickly. Two blocks of masses are placed on x-axis. The first mass 2 kg is removed on the axis. It is moved on the axis by a distance of 2 centimeters. So I can see 1 centimeter towards left, -1. चलो देखते हैं. Two blocks of these given masses are placed on the x-axis. ये रहा x-axis. First mass तो कहीं ले लिया, ये 10 kg ले लिया, ये 20 kg ले लिया. First mass is moved on the x-axis by a distance of 2 centimeters. By what distance should the second mass be moved to keep the position of center of mass unchanged? इसकी बात कल हो गई थी, right? If you move this also by 2 centimeter to the right, तो क्या होगा? Center of mass का position उतने distance से आगे चला जाएगा. So definitely you have to move it back by some distance, ताकि center of mass वहीं रहे. तो चलो let's continue, let's complete this one. इसका मान लिया हमने origin पे है ये, right? ये origin पे रखा हुआ है. So this, let us say the distance is d. तो इसका क्या होगा coordinate? d is 0. Now if you see the center of mass, what will be the center of mass? 10 into 0 plus 20 into d. That's 20d divided by 30. So you're gonna get here the coordinate of the center of mass as 2 by 3d and then 0. Right? And now what is said कि इसको हमने देखो अभी के अकॉर्डिंग हमारा सेंटर ऑफ मास कहाँ है? 2d by 3, 0. और ये मास हमारा यहाँ पर है 10 kg. बट इसको क्या करना है? Of course you have to move it to the left, क्योंकि राइट जैसे ही मूव किया सेंटर ऑफ मास चेंज हो जाएगा. So let's say I'm moving it by distance x and you need to find x. तो अगर x मूव कर दिया तो ये कोऑर्डिनेट क्या होगा? -x0. Remember I'm moving it by a distance x. Okay. So ये क्या था? ओरिजिन था. यहाँ पर हमारा क्या हो गया? 10 kg and 20 kg you are moving it to the right by distance of 2 centimeter. तो ये रहा 20 kg. ये कोऑर्डिनेट क्या हो जाएगा? पहले d था, 2 सेंटीमीटर मूव किया तो d plus 2 and then 0. Right? And now just frame the equation. Center of mass क्या होगा? 2d by 3 ही होगा, and that's equal to its mass into its center of its coordinate. So minus 10x. Its mass into its coordinate plus 10 into d plus 2 divided by the total mass, that's 30. तो ये क्या हो जाएगा? 10 हो जाएगा और ये 0 0 दोनों साइड से कट जाएगा. मिलेगा हमारा 2d इक्वल टू -x प्लस d प्लस 2. तो यहाँ से हम सॉल्व करेंगे तो हमें x क्या मिल जाएगा? x को इधर लाओ, 2d को उधर ले जाओ. सो इट विल बी -d प्लस 2. Let us check the calculation once, guys. Because ये d minus 2 क्यों आ रहा है? Let us see that. Its center of mass is unchanged and first mass is moved on the x-axis by a distance of 2 centimeters. So where will the second mass be placed? ठीक है, तो हमारा ये आ रहा है, बट इट डिपेंड्स कि अगर आंसर में 1 सेंटीमीटर होगा जैसे मैं देख पा रहा हूँ, सो इन दैट केस ये क्या किया है, क्या होगा? ये 20 kg लिया होगा, ये 10 kg लिया होगा. सो अनलेस एंड अंटिल गाइस you are not mentioned कि where is 10 and 20, both the answers can be correct for the center of mass. That is to be always remembered. Number 11, two blocks of masses, these are placed along a vertical line. ठीक है, यहाँ पर भी मेंशन नहीं है 10 कहाँ है 30 कहाँ है, तो जनरली हम जो पहले होता है उसको नीचे ले लेते हैं, या ऐसे प्लेस किया हुआ है तो पहले को हम यहाँ ले लेते हैं, राइट। सो 10 kg यहाँ है, 30 kg। First block is raised to a height of 7 centimeter. By what distance should the second mass be moved to raise the center of mass by 1 centimeter? So of course इसका center of mass कहाँ होगा? Let us suppose यहाँ कहीं होगा। अब इसको हमने ऊपर उठा दिया तो center of mass भी ऊपर जाएगा, right? But we need center of mass to be raised by 1 centimeter. तो इसको कितने distance से raise करेंगे? So exactly same question guys. Just the thing is कि इसमें हमने x axis में लिया, इस केस में हम y axis को consider करेंगे। Let us do the homework questions from this. अब homework question में all have done these questions guys, because we will go through the homework questions quite rapidly. Locate the center of mass of a uniform plate having semicircular inner and outer boundaries of radii r1 and r2 as shown in the figure. So where will the center of mass be? For a semicircular ring, guys all have done the derivation to find center of mass of the semicircular ring या फिर semicircular disc. All have done guys? So I am assuming that you all would have done this. So what it says, this is a uniform plate. अब plate है तो area होगा, right? Plate है तो area होगा, तो इतना ही बस है area उसमें, because it is having semicircular inner and outer boundaries of radii r1 and r2, मतलब कि बीच में से इतने पार्ट को हमने हटा दिया। So we can assume this like एक semicircular disc है, and from that I am removing another semicircular disc of radius r1 और इसका रेडियस क्या है r2। So in this case let us first determine the masses, इसका मास क्या होगा, and then इसका center of mass क्या होगा, let's find out that. So अगर हमने इस पूरे का मास माना m, right, तो इसका मास क्या होगा? For 1 unit mass, for 1 unit mass will be m by pi r2 square by 2, correct? And then for this much mass it will be pi r1 square by 2, right? So this will get cut, this will get cut, तो इसका मास क्या मिल रहा है? m into r1 square by r2 square. Is this understood to all guys? कैसे हमने मास निकाला यहाँ पर? And center of mass of semicircular disc और semicircular plate क्या होता है? 4r by 3 pi. ये सभी को याद रखना पड़ेगा. So its mass into 4r by 3 pi. And from here you remove mass क्या है? m into r1 square by r2 square into 4 its radius r1 by 3 pi and divide by the difference of mass. Why difference of mass? Because from this mass you are removing this mass, so total mass of course, yes. So m minus m r1 square by r2 square. So after simplifying you're gonna get the result. So let's check. पहले तो m हट गया यहाँ से. So you get 4 r2 by 3 pi. I'll multiply here r2 square and here also r2 square will be there, ताकि ये डिनोमिनेटर सेम हो जाए न्यूमरेटर के, और ऊपर में क्या है 4r1 क्यूब डिवाइडेड बाय 3 pi r2 स्क्वायर, राइट। तो चलो ये तो सेम हो गया, एक हटा देते हैं, अब नीचे का रिवर्स हो जाएगा, सो ऊपर आ जाएगा r2 स्क्वायर बाय r2 स्क्वायर माइनस r1 स्क्वायर। लेट्स सी, 4r2 क्यूब माइनस 4r1 क्यूब डिवाइडेड बाय 3 pi क्योंकि ये r2 स्क्वायर ये r2 स्क्वायर कट गया, और क्या था r2 स्क्वायर माइनस r1 स्क्वायर. आई कैन राइट दिस एज r2 माइनस r1 into r2 plus r1, and I can take 4 common, and I can write this as 4 a क्यूब माइनस b क्यूब लगाएंगे, क्या होगा a माइनस b इंटू ए स्क्वायर प्लस बी स्क्वायर प्लस ए बी, राइट. तो ये कट गया हमारे पास. तो रिजल्ट हमारे पास क्या आया, सेंटर ऑफ मास का 4 इंटू r1 स्क्वायर प्लस r2 स्क्वायर प्लस r1 r2 divided by 3 pi into r1 plus r2, and that's our answer. That's the center of mass of this. Number one, guys. All of you understood this? Okay. तो याद रखना है ये 4r/3 pi, 2r/pi for the disc, for the rod which is bent in the semicircular form, or you can say semicircular ring. Number two, quickly, all will do, guys. Quickly, all will do this. Number two. So four particles of masses 2m, 4m, m and m4 are placed at the four coordinates indicated. M1 क्या है? This is 2m. This is 4m. This is just m, and you have another mass m4. What should be the value of m4 so that the center of mass, all of them are exactly at the center of the square? तो देखो m4 का तो वैल्यू पॉजिटिव आना चाहिए ना, अगर स्क्वायर के सेंटर पे है, सेंटर ऑफ मास, तो पहले पोजीशन कोऑर्डिनेट ले लो, ये 0 0 ले लिया, स्क्वायर है, सो लेट्स टेक द साइड ऑफ द स्क्वायर l ले लिया, तो इसका कोऑर्डिनेट क्या होगा l0, इसका कोऑर्डिनेट होगा ll, इसका कोऑर्डिनेट होगा 0l. So center of mass, if it is here, that means it should be L by 2, L by 2. So let's take the x coordinate. So L by 2 क्या होना चाहिए? Its mass into its coordinate, सबको multiply करो. So 4 ml plus m into L plus m4 into 0. So you will not determine, you will not be able to get this value of m4. तो m4 है कि नहीं, तो हमें y coordinate लेना पड़ेगा. Y coordinate भी क्या है? L by 2. That's equal to its mass into y coordinate, its mass into y coordinate, its mass into y coordinate, that will be m into L plus its mass, so m4 plus L, sorry, m4 into L, and divide by the total mass. Total mass will be 2m plus 4m plus m, that's 7m plus m4, right? So from here देखो L तो कट हो गया. Now just cross multiply, you will get 7m plus m4 is equal to 2m plus 2m4. So from here you see m4 सॉल्व करना है तो क्या मिलेगा, उधर ले जाकर सब्ट्रैक्ट करेंगे तो m4 विल बी 5m. क्या होना चाहिए मास? मास शुड बी 5m, right? Everyone understood this? Everyone understood this, guys? How we got here? The mass has the 5m value. Number 3 we will do. Quickly, all will do this number 3. Two particles of equal mass m are projected. देखो v1 v2 से project किया गया. What will be the path followed by the center of mass of the two particles? You have to find the path of the center of mass. Quickly, all should try this one. This last few questions we have, guys. All should be able to do this. All right, all would have done that. Two particles of equal masses here. The masses of both the particles are same and they are projected as shown here in the diagram. Now we have to talk about the center of mass. Just observe, इसका कंपोनेंट अगर हम लेंगे तो आएगा इधर v1 cos theta 1, इसका इधर लेंगे क्या आएगा v2 cos theta 2 और इधर आएगा v2 sin theta 2 और इसका कंपोनेंट इधर आएगा v1 sin theta 1, right? So these two particles of equal masses are m. What will be the path followed by the center of mass of the two particles? देखो, what we will consider that both the velocities are projected, and here in the diagram you have the velocities v1 and v2 at the given angles. So center of mass along the x-axis VCOM along the x-axis, what will this be? M into v1 cos theta 1 minus m into v2 cos theta 2 divided by m plus m, right? This will be the velocity of center of mass along the x-axis. ठीक है, ये हमने प्रोजेक्ट कर दिया था. We have projected this and let us try to get the trajectory of the center of mass. जैसे हम trajectory particle का निकालते थे, in the same manner we will get the trajectory of the center of mass. So for that you have to get the x and the y coordinates of the center of mass, right? तो हमने equation लिख दिया. तो x of center of mass क्या होगा? Let us say in time t, for given time t, you can get the x coordinate, because using x coordinate only you can get the idea about the trajectory of the center of mass. तो x coordinate अगर हमने लिखा, so we have to write with respect to time t, इतने time पे, right? Similarly you will get y coordinate. So y में initial velocities क्या है? Means basically its mass into its position coordinate after time t. So it will be m into ut, that is v1 sin theta 1 into t minus half gt square, right? This will be the position coordinate. And similarly you will have for another particle, वो भी ऊपर ही जा रहा है, right? But it's covering positive displacement along y direction. तो यहाँ पर भी प्लस होगा, प्लस m into v2 sin theta 2 minus half g t square. Everyone understood this, how we have added here? चलो मैं सिंप्लीफाई कर देता हूँ, ये masses कट कर देता हूँ and let's write the simplified equation. So x of center of mass क्या मिला? X coordinate, let's say x denote x center of mass, ये होगा v1 cos theta 1 minus v2 cos theta 2 into t by 2 and y of center of mass क्या मिला? mm देखो यहाँ से कट गया, v1 sin theta 1 plus v2 sin theta 2, इसको कॉमन ले लिया, into t by 2 माइनस कॉमन दिया यहाँ से and half g t square, देखो minus half g t square and minus half g t square divided by 2, so that will be into 2 by 2. तो ये रिजल्ट हमारा यही हो गया. So basically you get the values of x and y now, right? And here we are talking about the path followed by the center of mass. देखो इस x component के वजह से जो होगा center of mass, that will lie along the line itself, right? It will lie along the line. तो क्या हम x coordinate of center of mass can we take that as 0? देयर masses are equal, right? masses equal है तो इसका x कोऑर्डिनेट क्या होगा? सेंटर ऑफ मास का ओरिजिन पे होगा, राइट? हमने मान लिया ये ओरिजिन है, so let's take this as origin and with respect to this let us figure out the y. तो इस केस में t तो 0 है नहीं, that means this should be equal to this, right? That's what we got by equating it to 0. So v1 cos theta 1 is equal to v2 cos theta 2 and that's equal to 0. So from here what we can conclude by looking at this expression कि v1 cos theta 1 इसका मैग्नीट्यूड इक्वल है v2 cos theta 2. देखो v1 and v2 these are not the same speeds because it's written with speeds v1 and v2. So definitely either theta 1 should be equal to theta 2 or if you consider the speeds then v1 should be equal to v2 and in that case theta should be different. But anyways we don't need to care that much about इसको बिना हम इतना सॉल्व किए भी कर सकते थे. These were having equal masses. Center of mass कहाँ होगा? X कोऑर्डिनेट में सेंटर पे होगा and y कोऑर्डिनेट पे कहाँ होगा? It will be along this vertical line. So what will be the path followed by the center of mass? It will be straight line. So the center of mass will move in a straight line in a vertically up direction. And the condition should be given. ये कब हो रहा है? Straight line when v1 cos theta 1 is equal to v2 cos theta 2 or when this is equal to 0. Because इसके बिना हमारे पास क्वेश्चन में enough information ही नहीं थे to just solve them, right? We were not given enough information. Okay guys, so in the next class we will discuss the level 2 of this 6.3 homework section level 2. So all are required to do that homework section, whoever have not done, and then we will play the Kahoot in the next class. All right everyone, bye all of you and see you all in the next class.